linking work and work tasks to process, environment, and potential hazards. Narrated by Susan Arnold. The learning process of this module is to build process flow diagrams, linking work and work tasks to process, environment, and potential hazards. Let's start by taking a closer look at this technology by reviewing the major process steps. The first step in the AM process is to create a 3D representation of the product using CAD software. That file is imported into the printed software to guide the printhead. There is a powder reservoir and a build platform. To start this process, the reservoir is filled with powder. A roller or wiper blade rolls a layer of powder from the reservoir onto the build platform. The printer head applies one layer of binder, and then the binder is initially set by having an infrared lamp array pass over the top. Then the build platform lowers, the level of powder in the reservoir is raised up, and the process repeats until all the layers have been printed. What you end up with is referred to as a green part, the part made of powder fused together with binder, submerged in a bed of unfused powder. This is an important feature of the method because it doesn't require any support materials to be integrated into the design, which is a thing that is necessary for some other methods. Next, the green part, in its box of powder, is placed in an oven, usually overnight, where the application of heat cures the binder enough that the green part can be handled without breaking. Then it has to be removed from the bed of loose powder. This is usually done by digging the part out with a spoon or spatula of some kind, and then the harvested part is cleaned by having the loose powder blown off. This can be done in a glove box, something like a fume hood or downdraft table, or simply out in the open, depending on the particle size of the loose powder. After that, the green part is generally sintered in a furnace to remove the binder and fuse the powder material into a finished part. Sometimes they'll also backfill the voids created by elimination of the binder with a second material like bronze. The process in this binder jetting example starts with preprocessing, shown in the pink, starting oval. Bulk materials such as binder, solvents, and powders are obtained from a vendor. Optionally, these materials may be transferred to smaller containers, and the potential interaction between the worker and materials could present an exposure opportunity, in this case metal powders, which we'll talk about more in a minute. Steps for possible exposure to hazards will be highlighted in red text boxes with white text and a white border. You'll see process steps requiring employees to move parts or pieces of equipment from one location to another, but no intensive interaction with materials in purple, faint dotted pattern in the back. Occasionally, the print head is cleaned using a solvent solution as noted in Step 2. In Step 3, the binder reservoir is loaded with binder on an as-needed basis. The binders can be furan-based, phenolic-based, silicate-based, aqueous, or solvent-based. Occasional steps will be clearly labeled as such. In addition, processing steps that require employees to interact with materials and equipment will be in green boxes with the dashed border pattern as we continue through pre- and processing steps. In Step 4, the job box is loaded with powder, completing the pre-processing steps. As noted, print media powders include polymer powder, mineral sand or powder, metal powders including browns, stainless steel, tungsten carbide, and other alloys, and ceramic. Outputs include the product and fugitive emissions that we'll discuss in more detail shortly. Next, the green part is printed. Going forward, steps in blue with a solid border and backgrounds are processing steps that do not require employee interaction. As shown here, the printing step does not require employee interaction, but emissions of volatile organics could pose an exposure risk. Once done, the job box containing the green parts, submerged in the powder, are transferred to the curing oven in Step 6. Again, as shown with a purple border and a dotted background, Intensive interaction with materials is not occurring at this step, but employees do move parts or pieces of equipment, making this a point for potential contamination. In this case, metal powders can be found on surfaces. Next, the parts are cured in the oven, at which point the binder evaporates. Then the parts are removed from the oven and transported to the depowdering station. The part is depowdered. In both these steps, the potential for interaction with powders represents an exposure risk. Next, sintering happens. The part is transferred to the sintering furnace where it is sintered. During the transfer process, residual binder is also a potential exposure risk. Finally, the sintered parts are removed from the furnace. Depending on the part and its application, further processing, such as milling or polishing, may be occasionally necessary, at which point large particle airborne swarf is a potential exposure risk. The finished part is removed from the processing area and packaged for shipment. Finally, during post-printing and processing, at some lesser frequency, the printer may be cleaned or equipment changed over. Collectively, these materials present a wide range of hazards, from nuisance irritation associated with general particulates to systemic effects like carcinogenicity and sensitization, and reproductive hazards associated with some of the binder components. An interesting note is that a lot of the inhalation and dermal exposures in binder jetting occur during the harvesting task when the parts are removed from the powder bed, not during the printing itself. The printer manufacturer's demo videos infer that the process looks a bit like the image on the right, with large particle sizes that fall neatly into place and are easily suctioned away. But in the real world, the powders look a lot more like this, with very small particulate sizes that move about the workspace freely. You can see this technician is using a glove box to clean his parts, a practice that we highly endorse. A critical element of assessing AM-related exposures is to observe the process in the labs or workspaces and to determine the various tasks of each printing method where exposures are likely to occur. This is important for determining similar exposure groups and for determining how and where to break up or combine tasks for sampling or modeling purposes, considering parameters such as duration, frequency, and types of engineering controls. For binder jetting, our task monitoring was based upon mixing and loading powder, for materials that require mixing, of course, printing, and parts harvesting. For materials that did not require mixing, the loading powder was so short that it proved impossible to get a detectable result at a usable quantitation limit. So for those runs, mixing and loading and printing were combined.